The James Webb Space Telescope has truly transformed our view of the universe, enabling us to see further and more clearly than ever before. This revolutionary instrument, designed for infrared observation, has provided us with breathtaking images that have captivated audiences around the globe. The extraordinary images obtained by this large, infrared-capable telescope have sparked a sensation worldwide, leading to widespread sharing across various platforms. The significance of the James Webb Telescope cannot be overstated. It is safe to say that it represents the pinnacle of astronomical advancement in the history of human achievement thus far. The scientific observations made by the James Webb Space Telescope have proven invaluable, providing insights that fully justify the staggering investment of $10.1 billion made in its construction. The first images released to the world from the James Webb Telescope on July 12, 2022, were nothing short of groundbreaking. Experts believe that these initial observations demonstrated that the James Webb is operating at peak efficiency and is fully prepared to continue its mission of uncovering the secrets of the infinite universe. Among the remarkable images captured are the cosmic scene in the Carina Nebula, the exoplanet WSB 96b, the South Ring Nebula, Stephan's Quintet, and the stunning deep field view of the universe. These images have given us a glimpse into the beauty and complexity of the cosmos. Although these were only the first images, since that time, the James Webb Telescope has continued to provide scientists with an array of even more spectacular and stunning images of the universe. Some of these images have left experts, astronomers, and cosmologists in awe, leading to the publication of many significant astronomical articles. However, amidst this excitement, some of these papers have generated a wave of panic among cosmologists because the new findings seem to directly contradict the established Big Bang theory, which has been the prevailing cosmological model for decades. For those interested in keeping up to date with the latest news from the universe and its surrounding mysteries, we invite you to subscribe to our channel. By doing so, you can stay informed about our ongoing explorations and discoveries. Also, be sure to like this video and turn on the notification bell to receive updates on our latest content. To better understand the implications of these new findings, it is essential to first grasp what exactly the Big Bang Theory is. The Big Bang Theory is a predominant cosmological model that explains the evolution of the observable universe. This theory was developed from careful observations of the universe's structure and various theoretical considerations, providing a coherent narrative for how the universe expanded from an initial state characterized by extremely high density and temperature. According to the Big Bang Theory, the universe originated from an incredibly concentrated singularity, a point where the conventional concepts of space and time lose their meaning. Based on meticulous measurements of the universe's expansion rate, it is estimated that the Big Bang singularity occurred approximately 13.78 billion years ago, plus or minus 0.02 billion years, which is also roughly the age of the universe as we know it today. Although the concept of the Big Bang may seem complex and daunting at first glance, it is fundamentally quite simple. The universe is continuously expanding, and the term Big Bang can often be misleading as it suggests that there was an explosion occurring at a specific time and location with a central point. However, in reality, the universe has no definite center. The Big Bang was an event that took place everywhere in the universe at the same time. This process of expansion occurred over time, rather than at a single point, resulting in galaxies moving away from one another without a central focal point. While we cannot directly observe the Big Bang itself, there exists observable evidence supporting its occurrence. For instance, the heat generated approximately 380,000 years after the Big Bang can be detected throughout the universe, which has been meticulously mapped by satellites such as the Cosmic Background Explorer, COBE, and the Wilkinson Microwave Anisotropy Probe, WMAP. During this early period, the universe was characterized by a smooth and simple structure with small temperature fluctuations, often referred to as ripples. The James Webb Space Telescope was specifically designed to image the first objects that formed as the universe began to cool following the Big Bang. Remarkably, it has succeeded in observing distances farther than those previously achievable by the Cosmic Background Satellite. Renowned scientists, including Professor Michael W. and Professor B.L. Story, along with Dr. M.A., the lead scientist of the James Webb Telescope project, assert that this advanced telescope could capture images of objects that formed hundreds of millions of years after the initial conditions established by the Big Bang. The small variations in temperature observed by earlier satellites may represent the nascent seeds that eventually developed into new galaxies. Although we do not have a comprehensive understanding of precisely how and when the first stars and galaxies emerged in the universe, the James Webb Telescope was specifically built to address this fundamental question. In summary, the Big Bang Theory serves as the primary explanation of how the universe came into being. This theory posits that the universe began as a hot, dense point that inflated and expanded at speeds that were initially unimaginable. Over the course of the past 13.8 billion years, this expansion has continued, ultimately leading to the universe we observe today. The Big Bang Theory has garnered widespread acceptance as the most plausible explanation for the origins of the universe. However, the recent influx of new images from the James Webb Telescope is causing some uncertainty among certain scientists regarding the credibility of this theory. For decades, most cosmology theorists have defended the Big Bang Theory as an unquestioned truth, but the new data from the telescope are prompting some scholars, including Alison Politic, an astronomer at the University of Kansas, to reevaluate everything they have done in this field. The extremely small, smooth, ancient, and surprisingly numerous galaxies observed by the James Webb Telescope are being deemed completely incompatible with the traditional Big Bang hypothesis. In the perspective of some scientists, the Big Bang posits that the universe is continuously expanding and that galaxies and other objects situated in expanding space should appear larger with increasing distance. However, the images captured by the James Webb Telescope paint a different picture, showing an increasing number of smaller galaxies, including those with luminosity and mass significantly greater than that of our own Milky Way. This observation suggests that the universe may not be expanding as previously thought, and the redshift of galaxies may not be proportional to their distance from us. In other words, the galaxies captured by the James Webb Telescope appear to be the same size as those in our immediate vicinity, indicating that the universe is not experiencing the expected expansion. The images obtained reveal that the redshift of these galaxies is 2 to 3 times larger than predicted according to the established theory of an expanding universe. This contradiction raises questions about the validity of the Big Bang Theory, aligning instead with predictions of a non-expanding universe. Previous research based on data from the Hubble Space Telescope had shown a redshift of up to 5, which aligned with the expectations of a conventional, non-expanding space. Proponents of the Big Bang Theory anticipated that they would observe galaxies exhibiting chaos and destruction from collisions and mergers. However, the images from the James Webb Telescope display smooth disks and organized spiral shapes reminiscent of present-day galaxies. According to researchers Eric Lerner and Ricardo Scarpa, these recent findings challenge the validity of the theory of an expanding universe. The data presented in the Panic paper indicate that there exists a far greater number of smooth spiral galaxies than previously anticipated, thus challenging the prevailing notion that galaxies share a common formation process. Lerner and Scarpa argue that this data effectively discredits the established theory of galaxy formation. Furthermore, the Big Bang Theory posits that the most distant galaxies observed in the James Webb Telescope images should resemble their appearances approximately 400 to 500 million years after the universe's inception. However, some of these galaxies exhibit stellar populations that are at least 1 billion years old. According to the Big Bang Theory, nothing could have originated before this time frame, leading the authors of the Panic paper to believe that the existence of these galaxies serves as compelling evidence that the Big Bang did not occur as previously understood. In a forthcoming study to be published in April in Monthly Notices of the Royal Astronomical Society, researchers conducted a detailed analysis of a cluster of nearly extinct stars of enormous antiquity known as HB1. This extraordinary cluster resides about 21,500 light-years from Earth within the central bulge of stars at the heart of the Milky Way. These ancient stars serve as true fossils, revealing what the early days of the universe were like when the first generations of stars formed using only hydrogen as their primary material. To the general surprise of the scientific community, a team of astronomers has found some of these ancient stars located within our galaxy. Observations necessitated the combined power of 2 large telescopes, one situated in South America and the other being the Hubble Space Telescope. By merging their data, the researchers were able to determine the age of the stars in the cluster, which turned out to be an astonishing 12.8 billion years old. This discovery places them among the oldest stars ever found, both within our galaxy and in the universe at large. This cluster of stars, as noted by Stefano Sosa, a co-author of the research, serves as an ancient fossil buried deep within the central bulge of our galaxy. The researchers have successfully dated it to a time long ago when the universe was still very young. These are indeed some of the oldest stars we have encountered anywhere else in the cosmos. Thank you so much for watching the video. We appreciate your support and encourage you to remember to like and subscribe to our channel. By doing so, you will be supporting our continued exploration and dissemination of knowledge about the universe. We look forward to seeing you soon for more exciting updates and discoveries.